talking about chapter 4, Isomerism 1. Let's get rolling. Isomers, same molecular formula but different in some way. Conformational isomers can be presented in Newman's projection. Different kinds of strains on isomers that affect the heat of combustion of isomers. Constitutional isomers, the index of hydrogen deficiency, and saturated and unsaturated, and fats and oils. So we're back rolling. So we're going to be talking about types of isomers. Meaning isomers, like we said earlier, they have the same molecular formula but different in some way. Isomers, if they have the same connectivity, then they're stereoisomers. If they don't, they're constitutional isomers. Stereoisomers, if they're different by rotation about single bonds, then they're conformational isomers. If they're not, then they're configurational isomers. And if they're configured isomers with mirror image, if yes, they're enantiomers. If they're not, then they're diastereomers.
Conformational isomers. Conformational isomers are isomers that have the same connectivity but they differ by rotation about a single bond only. Because in a single bond we have sigma bond, and in a double bond we have both sigma and pi bond. If you rotate a double bond, you break the pi bond, which is not supposed to happen. So you can only rotate with a single bond. So and this can be illustrated by Newman projection. Newman projection is a 2D representation of a molecule viewed down the bond of interest. These are the simple steps in drawing Newman's projection. The first step, two atoms connected by the bond of interest is shown explicitly. The nearer atom is depicted as a point, while the more distant atom is depicted as a circle. The bonds in the front converge to a point, while the bonds at the back connect to a circle. This is a good example of Newman's projection. We're going to be using ethane molecule. This is the bond of interest between two atoms, and this is the atom that is connected to a point. This is the front atom, and this is the more distant atom that is connected to a circle. Now let's talk about conformation analysis of ethane. Ethane can both be eclipsed and staggered. In an eclipse conformation, the carbon to hydrogen bond in the front eclipses or covers the carbon to hydrogen bond at the back. And in a staggered conformation, the carbon to hydrogen bond in the front bisects the carbon to hydrogen bond at the back. And in an eclipse conformation, we have more energy and they are less stable. And in the staggered conformation, we have less energy and they are more stable. So now, a torsional strain is an increase in energy that arises in eclipse conformation. That is why in an eclipse conformation we have more energy.
Steric strain. This is the increase in energy due to electron repulsion between atoms or group of atoms that are not directly bonded together but occupy the same space. Now let's talk about anti-conformation. Anti-conformation, this is when the bulky groups are 180 degrees apart from each other. This is an example here. You see the chlorine atoms are the bulky atoms here, and they're 180 degrees apart from each other. Now the gauche conformation, this is when the bulky groups are 60 degrees apart from each other in the Newman's projection. Now, as we see an example here, the chlorine atoms, which are the larger atoms, are 60 degrees apart from each other. Cycloalkanes and ring strain. Ring strain is the increase in energy due to the geometric strain. Now we're going to look at 4 different cycloalkanes: cyclopropane, cyclobutane, cyclopentane, and cyclohexane. Now for cyclopropane, because of its geometry, it can only be planar. That is, no matter how the carbon atoms rotate or move, they will always be planar. But and then it cannot reduce its strain. But cyclobutane, because of its geometry, it could actually reduce its strain to form a poker conformation, and this would help reduce its ring strain. Now for cyclopentane can the 4 carbons atoms are in the same plane, but the 5th one is in a different plane, and this forms as an envelope conformation, which also reduces strain. Now for the cyclohexane has it can go into the chair formation. Now the chair formation is the makes it lose all the ring strain, which gives it less ring strain and makes it more stable. Now, so therefore, we see a decrease in ring strain as we go from cyclopropane to cyclohexane. In fact, cyclohexane almost has no
We
ring
think
strain.
cyclohexane can form chair conformation. And here the energy diagram of cyclohexane chair flip. From chair conformation to half chair conformation is ending ring strain, so the energy is increasing. And from half chair to the twist boat, the ring strain is slightly decreasing, so the energy is decreasing. From twist boat to the boat conformation, the ring strain is slightly increasing, so the energy is increasing. And from boat to twist boat, the ring strain is slightly decreasing, so the energy is decreasing. And from twist boat to the half chair conformation, the ring strain is increasing, so the energy is increasing. And then from the half chair to the chair conformation, the ring strain is decreasing and the energy is decreasing. So the half chair, twist boat, and the boat conformation in a chair flip are higher in energy than the chair conformation itself due to the ended ring strain.
Moving on to constitutional isomers, they have the same molecular formula but differ in connectivity. They are also called structural isomers. If we take an example of C5H12, all these three that I've drawn here have the same molecular formula, but they are connected in different ways. This has the longest carbon chain to be 5 carbons, and so it's pentane. This has the longest carbon chain to be only 4 atoms and a methyl group on the second carbon. This has the longest carbon chain of 3 atoms and 2 methyl groups on the second atom, therefore dimethylpropane. Index of hydrogen deficiency, also known as the degree of unsaturation of a molecule. This is the equation that's used to calculate the index of hydrogen deficiency. N stands for the number of carbon atoms in a molecule, H stands for the number of hydrogen atoms in a molecule, M stands for the number of nitrogen atoms, and X stands for the number of halogens. If you have 2 different halogens, if you have a chlorine and a bromine in an atom, it will still mean that you have a halogen, so X will be 2. The number of oxygens in a molecule doesn't affect the index of hydrogen deficiency of the molecule, so there is no space for the number of oxygens in the equation. Saturated. This means that the molecule has the maximum number of hydrogen atoms possible, while unsaturated means that it has fewer than the maximum number of hydrogen atoms possible. If we take an example of CH3CH2Br, we can see there's 2 carbons, 5 hydrogens, 1 bromine, and no nitrogens. If we plug that into the index of hydrogen deficiencies formula and we calculate it, we get a hydrogen deficiency of 0. That means that the molecule we have here is a saturated molecule. If you have another molecule and you get the index of hydrogen deficiency to be greater than 0, it means that you have a molecule that is unsaturated.
Summary of what we talked about in chapter 4. We talked about isomers. Isomers have the same molecular formula, but they differ in some way. We talked about conformational isomers, which are isomers that have the same connectivity but differ by rotation about a single bond. We also talked about Newman projection, which is just the 2D representation of a molecule viewed from the bond of interest. We also talked about eclipse conformation and staggered conformation. Eclipse conformation, this is where the CH bond eclipsed the other. While staggered conformation, this is where the CH bond bisects the other. We also talked about anti-conformation, which are bulky groups of molecules that are 180 degrees apart. And while gauge conformation, these are bulky groups of molecules that are 60 degrees apart. We also talked about different types of strains. We talked about torsional strain, steric strain, and ring strain. Then we also talked about constitutional isomers, which are same molecular formula but differ in connectivity. We also talked about index of hydrogen deficiency, which are degree of the molecule's unsaturation. We talked about saturated and unsaturated molecules. Saturated molecules have the maximum number of hydrogen, while unsaturated molecules have fewer than the maximum number of hydrogen.